What is up, everybody? We got a good news, bad news situation. The uh, the bad news is us trying to create an NFL simulation engine just in Claude Chat was a spectacular failure. Even with the specification, I just kept passing it between agent and agent, and it would just keep finding fixes, and putting in more generic data, putting in more generic data. So eventually I had to actually incorporate it into my ideal software development workflow. But that leads us to the good news. Good news is we have a working approach, and we just hit a really critical milestone that will hopefully allow me to finish creating the simulation engine this week. So what we can see here is just a really simple React app that still heavily leverages the spec. Um, so, other good news, that wasn't a waste of time. That was still very important to know everything that was going on there. But what I'm doing is I have an analytics and data section, which is going to allow us to actually aggregate and pre analyze a lot of the data on all of these teams just to do spot checks, get a sense for what looks good, and ensure that we can do things step by step and that the AI isn't completely misinterpreting the requirements or uh, not calculating things correctly. I found a bunch of wild stuff in the chat version where even though I specifically told it average this column, it just didn't average it. It invented its own formula. So this allows us to get ahead of that. We can go a little bit more step by step. And then eventually we're going to come to the simulation engine, which will allow us to pick our teams, specify the point spread. This reverted. Oh yeah, there we go. These legends are wrong. Oh, that's an easy fix. And then I'll be able to run the simulation, see those results. But for now, you can't have the simulation if the data isn't right. And so we can go ahead and upload the CSV. And now we're going to be able to see all the analytics. So right now I only have two categories. There is the team profiles themselves. So this is categorizing all of these teams into are they good, neutral, or bad based on their rushing ability, their passing ability, and then how well they do on defense against those same categories, kicking, returning, and then more personality based groupings. So their pace, discipline, aggressiveness, and their style. So this is going to be really critical for how we also want to implement fallback logic. Is obviously there's not a lot of data sometimes when you get to the very narrow parts of the game tree. How many times do you have a third and 19 from the 5 yard line, for example, or something along those lines when you're in the red zone? So we're going to want to be able to group these teams together based on their personalities and based on their skills to make sure that we're not letting tiny little data points completely mess up the simulation as a whole. And here we can see a lot of this is just going to confirm with what we already know. We look at the best rushing teams, Jonathan Taylor, Indianapolis, no brainer. With what Rico Dowdle's been doing the past 2 weeks, makes sense that Carolina's up there. And then some sneaky ones. You don't think that Kansas City's actually that good of a rushing team, and that's just because they don't rush very often. But when they do, they're surprisingly effective. Um, Looking at some of the bad ones, New England, I'd imagine a lot of that is going to be turnover driven. Las Vegas, Seattle, Tennessee. And we can look at the offensive passing. Detroit, that's no surprise. Darnold and Jackson Smith and Najigba have just been absolutely killing it from an offensive passing perspective. And then, yeah, Drake May, sneaky good. We know Tampa Bay has been killing it. Daniel Jones, obviously quite good as well. And then, yeah, same sort of thing down the line. We have what we know is historically bad defense this year. Baltimore, worst defense against the run. And they're also the fifth. Uh, these are the good defenses. They're also the fifth or fourth worst defense against the pass. So this is just a good way to kind of get a sense over at a high level everything within the league. Coming over to the personalities, the slowest paced team is the Jacksonville Jaguars, averaging 31.7 seconds off the clock for each play. There's only a 40-second game clock, so they're almost always bringing this down. And then New Orleans, Cincinnati, Washington, some of the fastest playing teams in the league. This could theoretically have value for fantasy as well as just picking games. And then penalized, a lot of teams with around a 10% penalty rate, which obviously isn't bode well, could easily halt drives. Whereas teams like Detroit, Baltimore, Pittsburgh, Pittsburgh's a cool example. They're a very neutral offense overall, but they're very disciplined, so they can keep drives alive a lot easier. This is allowing them to put up points on teams despite them maybe not having the best analytical metrics. And then we can see the aggressiveness, how people are, how often are teams likely to go for it on fourth down, go for 2-point conversions, etc. This one was a bit surprising. I did manually validate the data, and it must just be because Detroit's not in a ton of situations where it actually makes sense to go. But they're currently one of the most passive teams in the league. So it just goes to show you that even though when it comes to some of these rarer things, the data might not necessarily plan out. But that's also why it's really important that we want to be able to make sure that all these things get blended in. And then stuff. So like I mentioned before, the Chiefs are one of the heaviest pass first teams in the league. This is just a ratio of all their pass plays to run plays. Um, and then same thing on the run first. Detroit is actually the only team that runs more than they pass. And the Jets, Seahawks, Pittsburgh Steelers are some of the other ones that are skew a little bit more run heavy relative to the rest of the league. But what I'm most excited about is I finally got it down so that our pass offense, all the different statistics associated with how good what a team does on offense are now complete. And I validated all the numbers. Everything looks perfect. So now I can just take that same workflow I was using and we can go category by category by category until all the statistics are done. And then we'll get to wire up the sim. And I'm hoping we'll be able to do that by Saturday so I can start using it in this week's games. So we'll come over here to the pass offense, and you'll currently see it's blank. And that's just because depending on what we want to do, the situations we evaluate these things on could be a little bit different. So let's take a look at like our sack rate allowed as an example. Now that we've selected sack rate allowed, there are different situations that we can bring this on. And so in this case, this is essentially saying, all right, how often do teams allow sacks as a percentage when they're away on early downs and then when they're away on late downs. So based on some of my initial data profiling, we wanted to incorporate some semblance of an idea of like home field advantage, or at least have that cut out or be personalized by team. And then there are distinct sack rate differences when quarterbacks drop back on early downs and late downs, which obviously makes sense, right? On third down and fourth down, you need to get a first down. So you're not going to be just throwing the ball away. You're going to try to extend the play. You're going to have more sacks, realistically, in those situations. But then we can take a look at this and see, in this case, right, Las Vegas, they allow the most sacks. No wonder why they're awful. And then Jacksonville, Carolina, Denver, Tampa Bay are some of the best in this scenario in terms of the percentage that they're allowing. And then you'll notice here, we also have the amount of plays, the similar team average. So again, we're taking, in this case, because it's the pass offense statistics, these are all of the teams that are in that same pass offensive EPA. And so in this case, Jacksonville's neutral. And we can see here that neutral teams allow sacks at a 5% rate for early downs when they're away. And they're 50, so they allow 58% fewer sacks than similar teams of that caliber. And the league average also coincidentally is 5. It's a little lower here because we're not, we rounded, so they're 63% lower than the league average. And then we can eventually see how many plays similar teams have had when we evaluated these metrics, and then a blended rate. And so out of curiosity, I'm just seeing, yeah, so a good team's still 5. So basically everyone's 5 or 6. Like how good you are in general at passing, basically you just revert to the league average. But as we pick maybe a different metric, so let's look at our pass completion rate. Now we see that we actually have 32 different categories because we're evaluating this based on when they're at home or away, when they're in the red zone or not in the red zone, on early downs and late downs, and then short to go, mid to go, long to go, very long to go, because that's definitely going to dictate how far they're going to be pushing the ball down the field. And then the further you're pushing the ball down the field, the less likely you are to realistically complete that pass. And so if we take something like early downs, long to go, this is going to be our 1st and 10s. we'll see here that some of our teams have, like, let's say in this case, 68 plays. We've effectively said within this is that if you don't have 50 plays or 50 plays that you can be graded on for a lot of these ratios, so any averages or ratios need at least 50 in the denominator, we're going to start blending in similar teams to you. And then if you still don't have 50, we're going to start blending in the league average. So for Team New Orleans, 74% completion rate on first and long or early and long when they're at home, not in the red zone. They have 68 plays that meet this criteria. Their pass completion rate blended is also going to be here 74%. But we invert this and we look at a team like Minnesota. They've only had 18 plays. So in this case, it's saying that they only have a 56% pass completion rate, but there was a really limited sample size. So we're going to start blending in the other 32 plays that we need here in order to be able to get that average. So we'll see now their pass completion rate blended is actually 61% because we're saying, hey, this is probably a fluke. They're going to revert back to what their similar teams are doing. Similar teams are completing at 64%. So therefore, that got blended based on the ratio of how many plays were there. And this holds true even for super, super rare circumstances. So like if we go look at in the red zone, early downs, mid to go, some of these teams don't have any plays. So New Orleans, in this case, no plays that meet this particular criteria. But similar teams from these bad offenses do. So their average completion rate is 41%. These are teams that are bad. This is a really cool example where we can see why that original classification is so important. Bad teams only complete passes 41% in this scenario, whereas a neutral team completes at 20%. And and then a good team completes at 69%. So this is a really key insight into why this blending logic is going to be so important. You take a team like Cleveland versus a team like Detroit, even though we don't have any data on either of them. We have one play in this situation for Cleveland, one play for Detroit, but we know Cleveland sucks and we know Detroit's awesome. So we can look to those similar teams, and then sure enough, when we look at those blended rates, when we eventually get to the simulation, Detroit's going to be completing passes at a 66% rate for this scenario, whereas Cleveland's only going to be completing things at a 54% rate. And so this is unique too, because now we're not just looking at a generic home field advantage. We're actually looking at if you're a good team and you're at home, how do similar teams play in these two situations if there's not enough data specifically on you, which is also why we see so much noisiness in home field advantage year over year. You think back to the Seahawks and the Ravens always having historically good home field advantage. Well, that's probably because maybe situations like this, where a home team in general, a good team is going to be much more pronounced. Just to kind of test that theory, let's look at home, red zone, early downs, mid to go, but we're going to swap it so that it's the away version of this. So we'll go away, red zone, early downs, mid to go. And let's take a look now. So now here we can see the good teams complete at 79%, 65% for neutral, 48% for bad. So this is a situation where it's probably still a little noisy. In this case, the away teams are actually completing a little bit better if they're good, but that's actually maybe a decent thing. The best teams mitigate maybe those disadvantages of playing on the road, and they continue to stay elite in those situations. In this case, it's probably just some noisiness, and the system accounts for that. At the end of the day, we're going to be falling back to the league average, which is 63% here. And then just out of curiosity, I can't remember what it was. Away, red zone, so home, red zone, early downs, mid to go. 59%. Yeah, that's kind of funny. Yeah, it just goes to show sometimes how the randomness works there. But either way, so how did we get here? And so I ended up developing in a multi-agent workflow where effectively we can come over here, and this is my IDE. I use Z, and I use a tool called OpenCode, which is great at configuring and setting up all of these different types of workflows and can use different LLMs that might be better within specific areas. So the most important things that I want to call out here is on the left, I have a documentation structure. So from the get-go, I know that I'm going to be writing temporary files to help us in the process to kind of understand what we've been doing on a particular task. But everything starts with what's the research that we need to do to be able to implement a feature based on what I want to happen. What's the spec that gets written, and then what's the implementation plan to successfully implement that spec, and then finally, what are the actual features and how can we document them. But how this ultimately works is I have a workflow that looks like this. And so essentially, we start where a user provides a request that goes to an orchestrator who essentially delegates to the correct agents for handling certain tasks. So we have a researcher, they ask some clarifying questions. I answer them, they take that research, save it off. An analyst then goes and writes a spec, which is going to be user stories, acceptance criteria, etc. Then the architect handles it. And then this is where I've actually found it to be most critical, is that I use a separate agent with a separate model that looks at the spec and the architecture document, reconciles them to say, hey, are there any contradictions? Was there something in the plan that scope creep wasn't asked for in the spec? Are there things in the spec that weren't addressed by the implementation plan? And this is actually one of the more critical loops. When we were just giving it to the Claude agent, it didn't have any of that. So it just ran with it. And then when it had a bad decision or made a bad assumption, those issues compounded. And so this part is really key, this handoff to ensuring we get upfront plans correct with a lot of approval before we start wasting time doing any development. We can then hand it off to a developer. I also have a fallback one that's a little bit more powerful. I have a free developer basically, and I have an expensive developer. So I try to use the free one wherever possible. The code gets reviewed and then documentation gets updated. So it's relatively pretty simple. And then each of these different agents have dedicated prompts that tell the LLM how to approach a scenario in a different way. So I come over here to the orchestrator, for example, and this is a really nice feature of OpenCode. But here we are coordinating complete feature development from research through documentation with automated sub-agent delegation. There's various tools and permissions that we can allow this, but then we actually give it rules, the workflow pattern, and then the steps. So in this case, this is where I'm clearly articulating, hey, every time you're in a new phase, you're going to delegate to the particular sub-agent using any related artifacts that we created along the way. So in this case, research, hey, researcher, analyze the code base for this feature, gather context, clarify questions, this is just a way to get the most up-to-date documentation for any technologies that we're using. The checkpoint is getting questions. We give the answers back, and then it's going to save that research report here. Then we hand it off to the analyst. It tells us that the research is in this location, and then so on, so on, so on. So enough talking. Let's actually show you how it works. So we're going to come over and run OpenCode. And so in this case, we're just going to now go talk to it. And you'll see here on the bottom right, I'm now in my Orchestrator agent. And we're going to give it a prompt. Our React app is looking really good. We just successfully implemented a whole suite of analytics and blending logic for our passing offensive statistics. Now that we know that works and the UI has been successfully tested and validated, we can now start quickly iterating through all of the other statistical categories. To start, let's create the same functionality for all of our rushing offensive statistics. So that is going to be any statistic from our comprehensive spec that uses the blending fallback logic of rush offense EPA. And then I'm just going to provide it the name of that comprehensive spec. And so this is just going to send that into the agent. And we're also going to let it know that the CSV is in this location if they need to reference it at all. And then, yeah, we hit go, and then it starts doing its thing. So in this case, we have a Chinese model, Kimi K2. And so it's going to take this prompt, and now it's going to begin that delegation process. Or at least I hope it does. I feel like whenever we do these live demos, something is always prone to go wrong. But so far, so good. It told us it's going to analyze it. It's now delegating that to our researcher, which is essentially an agent that we gave custom instructions to find all the relevant documentation that exists within the code base. So what I'm hoping it's doing here is saying, hey, he already told me that this passing offensive statistic features have already been implemented and built. So they should be able to find that same information within rushing. And we get a little bit of insight into what it's doing. Currently, it's reading some of our existing code in React. It just decided to start reading that comprehensive spec that we gave it. And then we just kind of sit and wait. So this is a little bit of the boring part. But yeah, it's I tried experimenting on some faster models. So one of the ways that I kind of validated which agents I wanted to use for each step was at first I tried just asking AI agents, but then I kind of ran into the issue where because all of these LLMs are so new, there's a lot of junk out there. There's a lot of speculation. And then depending on your provider from where you're getting these LLMs, there's some interesting nuance and things as well into what things can do. So, for example, like an LLM through Copilot might be really slow, but if you go through it, so sometimes it doesn't do what you're supposed to do. Um, the researcher never actually created its research doc. Please reprompt it and ensure that it saves off all of the relevant research to its specified location as part of its prompt. This is actually a good example. Because I pay for Copilot, it's essentially free whenever I want to do incremental usage. But as a result, Microsoft, of course, wants to put in a lot of middleware to make their costs low and save them money. So sometimes, especially during peak usage, when we run these Copilot models, I feel like sometimes they get stuck and then it just exits and they don't actually complete the task. That's one of the reasons why I'm actually using OpenCode's Zen, which just has pre-approved models that have been tested for coding for our really important steps like orchestration as well as developing, because you definitely don't want things just stopping when you're trying to orchestrate the workflow or doing development. So we'll see if this works on the second go around. But if I re-bring open this workflow, I can just kind of dive into each of the agents I chose. And so I tried using Claude Sonnet 4.5 as well as GPT as the orchestrator with Copilot originally. But like I mentioned, I think Copilot just does some weird stuff. So tool calls were just very awkward. So I just basically created a lot of sample tasks, would try them in isolation over here on the right in my IDE just to kind of test the performance, look at the outputs, get a sense for which I preferred. And so I ultimately decided on Kimi K2 for the orchestrator. For research, I almost actually picked GPT 4.1 because it was just so fast. So as you can tell here, like this is dragging on a little bit, but this is really just like, it just, the ultimate research findings from GPT-5 was just significantly more nuanced and in depth than 4.1. So I ended up opting for this anyway. But again, I only knew that because I was comparing it. And then when I was doing the analyst, I basically just fed it the research findings, and I gave the research findings to both Gemini and Sonnet 4.5 and compared them. In this particular case, because I wanted model diversity, I didn't compare GPT here because I wanted each one to be different, just so I could make sure I could leverage the strengths and weaknesses of each of the model providers. I liked both of their approaches. I thought they both wrote good specs. So then I gave both of them based on the specs they created. I swapped models. So I had the Gemini Claude create an implementation plan on the Gemini spec, and I had the Gemini model create a plan on the Claude spec. And I liked Claude's better. So I made Claude the architect and left Gemini as the analyst. And then we used GPT-5 to be that QA agent to, oh, didn't do it again. Um, See, I told you live demos never work. Um, I'm just going to throw this here. We'll give it one more time. And so this again was the important part. 3 different frontier models: Google, Anthropic, OpenAI, all making sure that they're all on the same page. So kind of getting sort of like a recursive consensus there. When this finds problems, it will inherently then tell it to go back to either the analyst if the spec was wrong, or the architect if the implementation plan is wrong, and then we get the handoff to the developer. And then sometimes when it's just like really long or complex implementation plans, I literally just gave it to GPT-5 Codex. This one is not using Copilot, so I have full control over the reasoning and the text verbosity, which just allows me to like really supercharge it to be optimized for just driving without any kind of supervision or review. Um, and then, yeah, the code gets reviewed. So in this case, GPT-5 was my code reviewer here. And then I use Claude on it, Haiku 4.5 as my documentation. So, oh my God, it didn't do it again. All right, what are we doing here? Why is it not actually? Hmm. It didn't ask for the clarifying questions either. Hmm. Let's try one more time. Please make sure that when you give it to the researcher, it completes its initial research, gives you questions to ask back to me. I will then provide those clarifying answers, and then it can complete and write its research documentation. So, anyway, we'll see. Um, if it doesn't work, I think hopefully we at least captured the spirit of the workflow that we're trying to do here. And while it would have been cool to see it go off without a hitch, sometimes that's just how these things go. Um, but yeah, um, that's pretty much it. Whoa, it read all that very fast. Okay, well, that's cool. Probably because it was all cached. The results, I would imagine. And now let's see if it actually writes something and asks me questions. I feel like a lot of the times you need to be like really explicit with these prompts to get it to correctly delegate. Um, and then so you make a prompt to fix one issue, and then that causes like a little bit of regression. So it's always a bit of a work in progress, and just goes to show you that again, AI isn't always a panacea, but hopefully we'll get it to do something here. And maybe this is a situation where I actually could be some Copilot issues. But yeah, I mean, I think this makes sense. We're saying it analyzes the code base, and yeah, you'll be invoked twice. Yep. Parse requests and identify areas. Get relevant documentation. Ask clarifying questions. So maybe it's getting confused actually by these tool calls here. And maybe I'll actually add that after the fact. What's interesting is it actually decided it got here. So before it wasn't even getting here. So there's definitely, I think, something weird with Copilot. This is it actually fetching the relevant documentation for TypeScript, uh, Vite, Tailwind, and then this is the technology I've used for parsing. So I definitely think there was some kind of an issue with the tool calls there. And there we go. Perfect. Finally it gets it right. All righty. All right. So similar team cohorts. Did it answer? Wow, the orchestrator answered it. So in this case, it actually answered it for them. But let me see if they're right. So yes, mirror the exact same passing approach. Use the run EPA turn. Okay, so that's good. Uh, is used run defense. I mean, I don't actually want it to do the defensive stats yet, but heck, if it ends up doing them both in one, I'm not going to complain. Yep, keep the same blending policy. That's correct. That's correct. That's correct. Okay. I mean, I'm not disappointed in that. Um, so it actually did answer it correctly. Normally, I would want a little bit of human intervention there, and I would want me to answer those questions. But you know what? This, I guess, kind of goes to show you how sometimes when you get these workflows fully automated, the AIs can just communicate to each other. And I'm very surprised it was actually correct there. So that's kind of cool. Either way, if we go back to here, I do think it makes sense to have that be in phase two because they don't really need to read all the latest documentation on the technology just to answer some clarifying questions. Really, that's going to be more along the lines of needing to know how to use certain technologies and structure the rest of it anyway. So I think this is actually fine and probably going to be better suited anyway. Um, and I bet it was getting stuck at those MCP calls. That's one issue I find with Copilot is it does struggle a little bit to leverage tool calls, probably just due to whatever all the metadata stuff that goes through it. But yeah, we'll bring this back up to full screen, and we'll see what this looks like on video. I'm hoping it'll be visible for you all, but um, I don't like messing with the size of everything because I find it's like really hard to get back to where I wanted. Uh, so if this properly hands it off to the analyst, I think we can probably let it stop there. But otherwise, I might just chill for a little bit and yeah, we can. I'll have areas to fast forward through the awkward silence in the eventual video. As we come back over here, though, I can at least start to, I guess, explain how we're going to use some of these things a little bit more. So when we come to this idea, right, of the simulation engine, and whether that's running a single game or running 1,000, we're really going to be using these blended rates to ensure that something happens. So let's say it's first down, and we're trying to determine what happens. first we'll have some tendency statistics as well. So how likely is a team to run or pass given that certain situation? And then when they do, we start with the most extreme first. So once they have decided to pass, first we're going to see if they get sacked. If they get sacked, we'll then see how often do they fumble. So in this case, let's say we're the Detroit Lions. Basically, we're just going to come down here and we'll say, okay, they allow, so let's say we're home, it's an early down, and we're at Detroit. They actually don't allow any sacks based on this criteria, which is kind of wild. But they've only had 37 plays. So we are still, even though they're really good, we're still going to blend in these similar teams. So we're going to go ahead and say, you know what? They're going to get sacked in this situation 1% of the time. And then we would go to the defensive team and we would see what is their sack rate when they're away on early downs. And we would essentially incorporate those two blended rates to figure out what's the actual probability of that happens. But what it would actually do is it'd be this relative to the league average. So in this case, we'd say, what is this blended rate relative to the league average? What is the other team's sack rate relative to the team average? And then offensive metrics are more predictive than defensive metrics. So we put a little bit of a transformer to reduce the rate of the defensive statistic. And then let's say there was a sack. Well, now we can go in and say, all right, well, what's the fumble rate? And obviously they never got sacked, but we might look at a team here and say, okay, San Francisco, league average is 8%. They've only fumbled the one time it's happened, so we're going to blend it and say it's 9. And then if they didn't fumble, then did they scramble? So then we look at their scramble rate, which isn't in here. But let's say they did scramble. Then we say, okay, how often do they get a touchdown? Or if they didn't scramble, now that means they ideally got off a pass attempt. So then what's that pass attempt completion rate? And then we would pick, let's just pick one that we know is going to be pretty common. So let's just go, yeah, home, non-red zone, early downs, long to go. And we go to, where were we? Detroit here. So yeah, they pass it 80% of the time, completion rate, but they only have 25 plays, so that's going to get blended in. So then 76% of the time, they completed a pass. Now that we know the pass is completed, we're always going to go with the most extreme first. So we would say, hey, what's our pass touchdown rate when our passes are completed? And we'd scroll down and see that, well, I can probably do this alphabetical because Detroit's early. 0% of the time, they have a touchdown in this situation on 1st and 10. So they had 20 completions. So again, we need to blend that. It's going to be a little too noisy. These teams typically are 2%. The average is 3%. So we're going to say 1% of the time. They're just going to have a touchdown. So then if we know they don't have a touchdown, let's see how frequently they have an explosive play. Come back down to Detroit. They have an explosive play 20% of the time. But again, only 20 yards here. And then 15% league average. So they're going to have 70% of the time they'll have an explosive play, which means we can basically say we know the yardage is going to be more than 20, but it's not going to be a touchdown. So now we get to basically look at their distribution and figure out how many yards and assign the yardage to that play in the simulation. But if it's not explosive pass rate, did they at least get a first down? And then we can go through and say, all right, in this case, they get a first down 50% of the time. And then that happens to kind of align with what good teams do in this situation. So that becomes their blended rate. And then all of these, each of these steps get compared with what the defense could do from that allowed perspective. And that's how the sim is eventually going to get built. And it looks like the analyst did successfully complete. Oh, this is the researcher. So yeah, very research intensive doc here. So it's basically said, hey, all of these things had previously been researched. Here's essentially things that you can reuse. Here's the architecture map. Here's the plan for how you're going to want to analyze the CSV. Here are the metrics we're going to need to bring in. And then the formulas that were specified there in the spec. And then, yeah, this looks very comprehensive. This is the one thing that AI is good at. Like, look at all my docs and tell me how I could approach a situation. So we'll go ahead and accept that change. And so we'll see the little green dot, and yay, we have our new research findings in our research folder. So now it's probably going to say, either, we'll see if it asks me for approval, or if it's just going to delegate directly to the analyst. So we shall see. Also, because of that back and forth, we used up most of its context window. So we'll see if it can compress automatically. Okay, cool. So it's sending it. Great. And now we've delegated to the analyst. Now the analyst is going to. Oh, nope. Yeah, there's definitely something wrong with. I think there's definitely something wrong with Copilot, and it's throttling right now. Um, I'm just not sure if I wanted to like switch completely to like ungated because I get all of the um, usage. I mean, it's effectively free because it's sunk cost, so I want to use it wherever possible. But it just really starts to struggle in some of these situations. So like literally, it like read this doc and then freaked out. Yeah, and now it's freaking out again. Yeah, so it's gonna try again. So at least it's trying. Looks like it might actually be creating the plan itself since our analyst was asleep at the wheel. Yeah, here we go. Um, yeah, I mean, this isn't, I mean, it's not bad. Um, I'm just going to compact the session and then we'll. Okay, so now it's saying what we accomplished. So they did the research, they created the document. It didn't actually create the spec. Oh, it did. I didn't accept that. Um, Now it's trying to develop. Okay. So what we'll do here is we're actually going to bring this over to the left. And then I'm just going to say, hey, can you update the following spec to ensure that it complies with the rules as specified in the following metadata file? And then we're just going to say at rushing statistics specs and rushing statistics. And then we're just going to cite our analyst. So, because it's freaking out, we're just going to go ahead and tell our little guy on the side. So, again, this is the benefit here. When things are freaking out, you can always follow through and follow up on a different side. And see, it correctly identified that the spec has way too much how. So it's basically just going to start it from scratch. There. So we stepped in, did a little manual override there. Now we're going to be like, now we can tell it, you know what, give it to the architect. Uh-oh. Architecture plan's not done. Oh, cool. It's delegating now. Got it. So now it read our research. Great. It read our spec. Now it's going to read all of the relevant code files that were probably cited in that spec and that research. And yeah, okay, cool. It's already preparing to write. So this one was way faster. Oh, maybe that's the problem. I did make the analyst Google, and Microsoft just hates Google. They never get along. Um, Google Gemini actually has a 1 million token context limitation. But guess what it is when you're using it in Copilot? It used to be 64,000. Literally, you're getting less than a tenth of the capabilities of the model. Um, I feel it's like some part of long con where Microsoft just wants to make Google look bad when it's used, especially when it's used in their products. But uh, now I think sometimes it's 128, but that could be one of the reasons why the analyst was sort of freaking out there. I did notice a lot of the times, uh, yeah, it just will just get like super jittery. So maybe I'll have to. I don't know. I did like the idea of like this like free agent back and forth. So we'll have to see. Maybe I'll give it to Chat GPT, and then I'll use a different model for research, since there's going to be models that have better tool calling ability, especially since I want to be like researching like the most up to date documentation and everything. Yeah, we shall see. But yeah, so it's doing its right. Oh, there we go, and it wrote it. So yeah, here we go. It's basically just asking for permission here. And yeah, pretty extensive. Looks like it's multi-step. I'm not going to scroll through all of this. Uh, this is the other nice thing about AI, right? Like I'm lazy, but like I read slow. AI reads fast. So we're just going to go ahead and accept it. And luckily, we have our design QA agent who's now going to reconcile the spec versus that implementation plan. And it'll tell us if it did anything wrong. So yeah, now it's going to give it to the design QA. I don't like that it created a plan presuming it already knew how things were going to get implemented, but maybe it will update itself a little bit more. So, yep, it's reading the plan, it read the spec, and then it also read the research. And now it's going to go through and it's reading all the relevant files. And so, again, this is just getting that third set of eyes on thing. We had Google, although Google was not working thanks to Microsoft. We had Claude, and then now we have OpenAI. So let me actually think here. Let's see. What else do we got? And GPTs. I originally liked the idea of using O3 as the reviewer. So in this case, I could have used um, GPT or Google Cloud or GPT-5 to write the spec and then have Claude to do the architecture, and then O3, which is still, I really like this model a lot, to be the QA design analyst. But I saw on Copilot's docs that by the 25th, which is like in 4 days, they're actually sunsetting it. So I was like, I don't want to get dependent on it in my workflow. Maybe I just try Opus. Um, I've never gotten close to like the 1500 premium tokens. So maybe I'll use Opus as the researcher GPT-5 to write the spec or something along those lines. Um, that could be kind of fun potentially. Um, so yeah, maybe Opus to research because that's going to be hopefully better at tool calls. GPT Analyst, Architecture Claude, GPT again for the review. That could work. Yeah, maybe that is the play, and then we'll see what our tokens are like. Yeah, this is reading a lot. It read the code. It's rereading the specs and the plans again. So it's very thorough. It looks like it read the plans and the specs for our offensive passing statistics, just to get a cross reference of some of these patterns that could be reused so that the implementation plan stays in sync with how we've previously implemented things. And then it's rereading all of those stats again. So, again, a little slow, but just ensures that we're thorough. Oh, God. So, identify the issues and. Okay. Well, ideally it would have outputted him for me, but it looks like this is still running through with it. So, okay. In this case, users can view. Oh, so it is going to do the defensive rushing metrics too. Interesting. Okay. I guess that's fine. I don't know if I want blended logic. I don't agree with some of these findings. We don't have tooltips on any of the blended values from our passing statistics, so we shouldn't have uh, tooltips on our new rushing statistics. I also explicitly only told you to create a new toggle button and statistics for offensive rushing metrics. I want to take this category by category so that things go smoothly. We don't run into these issues. And all of the patterns should exist already for our passing offense statistics. We should just be able to reapply them specifically to our rushing statistics, their respective buckets, and um, blend in the exact same manner using the tertiles for rushing offensive EPA instead of pass. Anyway, we're getting a little too into the thick of things, so we'll call it a day. Um, but yeah, hopefully this gives a little insight. Sorry you didn't get to see any development, but rest assured, I'm pretty happy with this approach, and I've been developing pretty quickly. So I think we'll have a more exciting video, which is just going to be us betting or understanding what bets to place in our competition using this new simulation engine that we're developing. So until then.